All right, hi everybody. I just wanted to kind of go over just a little bit more on graphing. Okay, so this is going to be more so a graphing review for your exam. Okay, so the first thing I just want to like kind of recap from class, right? You had the graph that said speed versus time. And this is like a terrible axis, so let me draw it a little bit better. So we had 0, then we had 1, 2, 3, 4, 5. And then here we had 5, 10, 15, 20, 25. Okay, and the line went something like that. Obviously, I don't have any grid marks on mine. No big deal. So then it said, what was the total distance traveled? Okay, in the first 4 seconds. I do apologize if you hear like walking around or like growling or whimpering. My dog is in the background and she's like crying because like I'm not sitting with her. So I apologize if it's like annoying in the background. Okay. Okay, so with this graph, right, when we are looking at a graph and we're like, hey, what things do we need to have? We have to go to our reference table to find a formula that matches. So I want something that has V, T, and D, which turns out to be the first equation, V equals D over T. If you multiply T on both sides, okay, these will cancel out. You're left with D is equal to V times T. So basically what that means is you're multiplying the X and Y axis. Or axes, whatever. Okay. However, and I just wrote the arrowhead to the wrong thing. Okay, so this indicates we're multiplying them. Okay. So if I go take a look at my, hold on, I gotta move my dog because there's just no way that I could keep doing this. Sorry about that. Okay, we're back. All right. So we're going to multiply the X and Y axis. The problem is, like right here, we put a line there because we don't care about what's happening over here. We focus more so what's going on underneath the line, right? This red line from 0 to 4 seconds. So we see that there's a triangle there. So we're not just multiplying speed times time. We have to take into account the shape matters. Okay, so shape underneath line matters. So what I mean by that, in this case, our distance is going to be equivalent to our area. And in this case, we have a triangle. So we have 1/2 base times height. So when we go to substitute, the area of our triangle will be 1/2. The base here is going to be 4 seconds. And the height will be 20 meters per second. Okay, so your area of the triangle will equal 40 meters, which is really the displacement of this, the distance of this object for the first 4 seconds. Okay, so that's a really important theme. When we multiply the axes, right, we're taking the area. When we divide the axes, that means we're taking the slope. Okay, so again, area means the shape matters. Slope means you're choosing 2 points that touch the line nicely. Okay. Oops, let me move this down a little bit. Okay, so let's do like an example for slope, right? So again, we'll have a distance versus time graph now. Okay, and here's the origin 0, 0, 1, 2, 3, 4, 5, 6. We have 2, 4, 6, 8, 10. Okay, so we have this nice kind of line here. So basically, obviously, if I had grid points, we would see like, hey, this hits pretty nice. This is also another point. This is another point. This is another point. And there you go. Okay, so we have really nice points. So we're going to choose 2. So this says, what's the average speed according to this graph? Okay, so again, you want to look for a formula that has v, t, and obviously the letter v. So we have v is equal to d over t. So we see this operation division, and we know right away, right? I have the division of, the y-axis and the x-axis. Can this go away? Okay. So when we do that, that means we're actually going to take the slope. So this is where we're going to choose 2 points. So I can take this one right here, this one right here, or I could even take the origin too if I really wanted to. So remember, slope will be a change in y over a change in x. So y2 minus y1, or x2 minus x1. So in this case, slope is equal to, we have the point 4 meters minus 2 meters over 2 meters minus second minus 1 second. So you end up with 2 over 1 meters over seconds. So your slope, or your speed v, your average speed, is going to be 2 meters per second. Okay, again, how did we know that we have to take the slope? Our formula, the division tells us we have to take the slope. That's what I keep talking about. When you divide the x and y axis, that is taking the slope. Okay, so if an equation has division, that means you're going to take the slope. When an equation has multiplication of the x and y axis, that means that you're going to be multiplying. You're going to be taking the area of the graph. Okay, so let's do another graphing example. All right, so I always love the questions about same motion. I think they're pretty stellar, just because I like them. I think that if you make sense of what the graph is saying, it really makes your life really easy, right? So A, C is this. So you have D versus T, V versus T. Let's see, I got B, D versus T. I have something that looks like this. I got this. And then finally choice D. Okay, so let's actually talk about what's happening for each graph. So we always read graphs from left to right. So we always pay attention to what's on the y-axis. So I would circle that. So as time is increasing, my distance remains constant. So again, we relate objects to either they're at rest, at constant velocity or motion, or they're accelerating. Okay, so those are the big 3 that we keep talking about. So that's what we always are going to refer to a graph to. So if my time increases and my distance does not change, this object is at rest. As my time is increasing, my speed changes. This is known as an acceleration. So these are not the same type. If I look at choice C, as time is increasing, my distance is increasing, right? It goes up, but it goes up at a non-constant rate. So that means that this represents an acceleration. If I were to look at the other graph, right, with V versus T, as my time is increasing, my speed remains constant. So this is at, constant motion. So that's obviously not good. Then if I take a look at choice D, I see as time is increasing, my distance increases non-constantly. So we said non-constant increase of slope is an acceleration on a D versus T graph. On a V versus T, as time is increasing, my speed increases, which is literally the definition for an acceleration. So choice B is your solution. Let's make sure choice D is not good. I realized I did not finish drawing the line. LOL. So again, we take a look at our graph here. As time is increasing, our distance does in fact decrease, right? And it's doing it at a constant rate, right? So if I were to take the slope, it's the same. So this is at constant velocity. And as time is increasing, our speed increases, and this is known as an acceleration. So choice C also shows that they are not the same type of motion. Okay? Another example that I think is good that you can be asked, right? So if we have a displacement versus time graph, right, and it looks like this, they can ask you, right, like what condition is this? So again, we have this linear line. If I were to take the slope here and the slope here, it's a constant slope. So that means we're at constant velocity. So that means that the velocity of the object remains the same. Okay, so sometimes when we see a graph that's going upwards, we get really excited and we think, oh, it has to increase. That's not true. We have to take into account what's actually happening on the graph, okay? So we need to make sure that we understand what's on the y-axis first, okay? Another example I'd like to go over. So we want to know which graph would represent constant acceleration. Okay, and the graphs that they give you are all velocity versus time graphs. Oops. C is V versus T. D is V versus T. Okay, let's talk about it. As time is increasing, our speed increases. So we know this is an acceleration. So how do we know if it's constant? Well, if I were to take the slope here and here, do I get a constant slope? Yes. So the constant slope here tells me that acceleration is constant in choice A. But let's make sure that the rest are no good. So as time is increasing, our speed remains the same. So this means we're at a constant velocity. That's not constant acceleration. Okay. When you're moving at a constant velocity, that means your acceleration is equal to 0 meters per second squared, because you can't have overlapping conditions. And then in choice B, as time is increasing, our velocity does increase, but if I were to take the slope here and here, this is a non-constant slope. So that means that acceleration is not constant here. Okay, so choice B is no good. And the same thing here. As time is increasing, our velocity does increase, but again, if I were to take the slope here and here, non-constant slope. So that means acceleration is not constant. Okay, so choice D is bad. So therefore, choice A is the only one that makes sense. And then finally, the last example before I let you go for the night. So I have time and displacement. We're just going to analyze sections of the graph, right? I'm just going to make sections. So this will be like point A, B, okay, so this is point C, D, E, and F. Okay, and we would want to identify parts of this graph. Where might this object be at rest? What time interval? Moving at a constant motion and accelerating. Okay, so if we look from A to B, I have this nice diagonal here. Again, a diagonal on a D versus T, when I take constant slope on a D versus T, that means I'm moving at a constant velocity. So we have this segment AB. Then I get to this segment right here, BC. So that means that at this particular spot, the object is not moving anymore, right? The distance has not changed. So BC, we're at rest. Then I look at DC, and I have this curve. So if I were to take the slope here and here, that's a non-constant slope. And on a distance versus time or displacement versus time, that means you have an acceleration going on. So from CD, then I go back to DE, I have a flat line again. So that means I'm at rest at DE because my object's distance is no longer changing or displacement. And then finally, we have EF, which is another diagonal now. So again, if I were to take the slope on those 2 points, I have a constant slope. And a constant slope on a distance versus time or displacement versus time indicates that you are moving at a constant motion. Okay, so basically on a D versus T, when you see acceleration on the graph, it's a curved graph. Okay, so hopefully this helps. Again, practice is what's going to help you on this test, not just watching this video, not just looking over the packet, but actually doing the problems. Okay, so again, I recommend that you do the make your own study guide so that you can get the +5 on tomorrow's test. Okay, good luck.